and welcome to Level Up Stronger. The world is continuously changing at a very rapid pace. How can we all gain the competitive edge in our industries and thrive in them? What if you knew without the shadow of a doubt that self-education and access to forward-thinking experts in your field could catapult you towards success faster than ever before? The spaces we inhabit can inspire us, protect us, define us, and connect us, so we all play a valuable role in shaping their future. We plan to take a deep dive into various industries and careers. What are the future of the industries? What are the barriers to entry? And learn from the very people who thrive in them. We will take you behind the scenes to the people, products, and processes that keep industries thriving. In this podcast, we look forward to inspire and empower everyone to take thoughtful, educated risks and apply what we've learned in our lives so we can all level up stronger.
Hello, I'm Julie Kramer, and I'm joined by my co-host Tiffany Laterly. In today's episode of Level Up Stronger, we have the pleasure of speaking with a panel of BAS engineers and technicians from Inspection Experts, a woman-owned small business enterprise based out of Columbia, Maryland, that performs facilities management throughout the United States and worldwide. IEI has in-house BAS and commissioning capabilities to serve clients from initial facility, construction, to maintenance and troubleshooting throughout the lifespan of the system. BAS can be used to efficiently operate building mechanicals and to control building climate, ventilation, lighting, and occupancy scheduling, as well as monitor system malfunctions. These capabilities serve to reduce energy consumption, operational expenses, and overall maintenance costs in the facilities where they are utilized. Together, our panel participants have nearly 50 years of experience in BAS and related fields encompassing both the public and private sectors. Richard Ramirez has been an HVAC engineer with IEI for 6 years, where he has led efforts on BAS technical support services for government facilities worldwide. He started his career as an HVAC mechanic serving the complex needs of commercial clients. He used these skills to transition into the role of HVAC application engineer in the building automation field, where he created control programs and graphical user interfaces and ensured adherence of engineering plans to design specifications and applicable electrical codes. He continues to use his diverse experience as an HVAC technician and BAS engineer to better respond to clients' needs and improve system design. Baron Holt has over 10 years of experience as a BAS technician and engineer. He currently provides BAS support on worldwide maintenance and repair contracts for Inspection Experts after previously working as an electronics industrial controls mechanic in the United States Marine Corps and various HVAC and controls, troubleshooting, service, and maintenance positions in the private sector. Baron holds a bachelor's degree in computer science and later went on to obtain an Associate of Science in Electrical, Electronic, and Communications Engineering Technology. Tony Barnes is a senior HVAC technician and BAS engineer at Inspection Experts, providing BAS services to government clients worldwide. He has a distinguished military career in the United States Navy and continues to serve as a Chief Petty Officer, Fire Controlman in the Navy Reserves. He previously worked as a site manager responsible for the upkeep and maintenance of 11 buildings at a Navy installation in Florida. He has also held various positions in the private sector to improve and establish controls of equipment and provide customer service and tech support. In addition, Tony was a facilities operator for the state of Florida, in which he was responsible for monitoring 40 state buildings. Thank you, Richard, Baron, and Tony, for joining us today for the Level Up Stronger podcast. I'd like to start off by asking you each a little about yourself, including your experience and when and how you got into the field of building automation systems. So why don't we start with you, Richard?
Sure. As you mentioned, I initially started as a HVAC technician. I had gone to school and earned an associate's degree for HVAC engineering. So I started working for an HVAC company down in Miami, Florida. And they focus mainly on commercial buildings and applications. So I did about 6-7 years working with them, doing those type of projects from installations, but mainly servicing commercial buildings. And then the opportunity came up to transition into a BAS engineer within the same company. So I took that opportunity. And ever since then, I started working on building automation systems, controls of different brands, mainly Johnson Controls and Tritium Niagara.
Thank you, Richard. Let's move on to you, Baron. Could you tell us a little bit more about yourself and your experience with BAS and how you got into the field?
I got into BAS roughly about 2013, 2014. I just got out of the military and I was working at a company in Richmond called Thomas and Betts. I was the test cell supervisor. I was looking for a change, and Siemens actually hired me. When I actually got hired, I had no clue what they were exactly doing. They just gave me a brief overview of what was going on, and they didn't go into depth. It wasn't until I actually showed up on the job and they started teaching me about building automation. And since then, I've just been in the building automation field. I've worked for Marine Corps Base Quantico as a BAS technician, and I've worked for Siemens twice before coming to Inspection Experts. Like you said earlier, I have a background in computer science and electrical engineering, so that helps a lot when I don't understand stuff or when I have questions.
And so what I'm hearing, when you started out, you did not intend to go into BAS. That was just something that came about later on as you learned more about it.
Yeah, I had no clue what they were doing, like what they exactly did. I just knew it was Siemens, and I just knew Siemens was a major corporation. At the time, I just wanted to leave my job, and I glanced over everything. I was like, oh, this looks great. I'll do it. And then they started explaining it to me. And I actually was surprised that they hired me because I had no HVAC background at all. So when I got hired on, they did teach me the basics of HVAC in the very first, I think it was like 2 weeks I was there. So they did have to teach me that. And then as far as the computer aspect of it, I already had an understanding of it. So it wasn't much to teach there, just learning their software and how it communicates and how it works. That was the biggest hurdles.
Thank you, Baron. I'd like to give Tony an opportunity. If you could tell us a little bit about yourself and your experience.
I joined the Navy in 92 and got out of active duty in 98. When I got out of active duty, I went to work for Siemens Building Technologies. At the time, it was Landis and Stafa, but Siemens bought them out. And that's where I got my start in the building automation side of things. The Navy training that I received had a lot of advanced electronics in it, everything from basic DC and AC voltages to radar theory. So a lot of my technical training and background came from the military training. Joined Siemens in 98, worked with them, got to know a lot more about actual building automation systems, whereas before in the Navy, the biggest thing that I had that worked almost in the same aspect was we had dampers that were controlled for the missiles. So when the missile shot off, you had dampers that closed all the ventilation so that the toxic fumes and stuff wouldn't get in the ship. That was what tied into the HVAC side of things. And once I got with Siemens, just like Baron, we got a lot of training and they brought me up to speed on a lot of the building automation stuff. And it's been in the industry ever since. So I've been part of HVAC and the BAS system since 1998.
So can you tell us what exactly, for those that are listening to the podcast who don't really know what building automations is, can somebody tell us a little bit more about building automations and give us the basic understanding of what it does?
Building automation basically is taking everything that you possibly can make the building perform, whether it's the air handlers or lighting or security, and tie it all into a computer. So little relays and little circuit boards and circuitry that's out there by a door or by an air handler unit or by a temperature sensor even reports back to a main computer server. And with that information, you can sit there and develop a action plan for preventative maintenance. You can look at the energy costs and energy savings possibilities of the building. Newer stuff nowadays is using AI to introduce the fact of learning the building so they can basically, instead of just switching on a switch for the air handlers to come on at like 5 a.m. to get the building ready to be occupied at 6, they go through and do a lot of calculations and say, okay, well, with the temperature right now and the outside air temperature and the amount of occupancy, we can start the unit at 5:35 and it'll be up to the set point at 6 a.m. for when the building is supposed to be occupied. There's a lot involved with that. And basically, you're tying a lot of information, a lot of peripheral devices into a single computer server and able to look at all of the things in the building and make some good processes and good decisions based off of what you can do to save money. Because that's what the bottom line is everybody wants to save money under the operations and maintenance of the building contract.
Well, and this would have an impact on sustainability for a building as well, right? So we can adjust parameters within the building, then we can achieve more sustainable results to the building, less energy cost, less carbon footprint, and all of that as well.
Absolutely. And it saves amount of time. Used to be the old way was they'd call the facilities maintenance guy and go up there and take a look at the temperature of the room and have to bring up a temperature sensor, where if it's all on the computer, you can bring up the room, see what the temperature is, see how the devices are working. And if you can determine that it might be a stuck mechanical damper, or just maybe that they've got more heat load in that room than they normally would, then you can make adjustments to the set point. You can do it remotely through the computer, and it's a lot quicker to access.
And we find that that's helpful, especially in courthouses. When court's in session, you have a room full of people. The normal conditions of that room are greatly affected by the number of people you're stuffing in that room. And so the technician can now sit at his computer and watch and make pre-adjustments to the functionality of that room or the temperature settings prior to court.
Absolutely. Instead of being reactive, you can be proactive and try to adjust things before it gets to the point of somebody complaining.
Thank you, Tony. And you touched on some things in my next question about some of the benefits of buildings that have BAS versus those that don't. I saw an interesting comparison. I don't know if you guys would agree, but building with BAS is like the smartphone and the antiquated systems in an old flip phone. But I don't know if you can speak to if there's any other advantages of the buildings with BAS and what you're seeing these days, or buildings that don't have it. Are they able to get up to speed? Challenges in adding BAS systems later of things that are not new builds?
I think it's even worse. I think it's the smartphone versus the rotary dial-up phone. Like, that's how bad it is in reality. When you have some, and Boyce can probably talk about that because it's significant difference.
One of the things I like also is if there's an issue in a building, say it happens around 8 p.m. at night when mostly everybody's gone home, the building staff, they're able to receive an email alert or a phone call advising them that maybe a chiller is down or a major malfunction happened at the building. And then they can probably have their on-call person respond to that emergency. And by the time the tenants show up the next day, if everything is fixed, then they wouldn't even know there was an issue. Otherwise, if they don't have that system, they might find out the next morning when it's too late. And then they have a lot of very unhappy people.
Thanks, Richard. Would you like to share anything, Baron?
I think part of your question was, can you retrofit BAS into a building? That can be done. You have to look at the age of the equipment and what you have in there. There's older buildings that have pneumatics and stuff like that. That's the older way they were controlling buildings. And that's stuff that you would have to take a look at. But most buildings that are older, you can retrofit a building automation system in there. And what it'll end up doing is saving you time, effort, and money and energy. Richard touched upon it. There are buildings out there where after hours, you don't have staff there, and it's a great thing to have remote access or just have the ability to get an alert. You can log in to get to the actual site and see what's going on before heading in, so you have a better idea of what's going on.
Yeah, and if I can chime in on that, when I worked for the Department of Management Services for the state of Florida, we had one central location that was manned 24/7, and we were able to remotely dial into approximately 40 of the buildings that were around the state. And exactly like you said, Baron, we were able to address things, and I could diagnose issues remotely and decide whether we needed to send an HVAC mechanic or an automation technician or electronics guy, and that saved time and money. And it was a way of giving that 24/7 access and support to the buildings that you have out there.
So in some of these older buildings where you would be potentially asked to implement a building automation system, what are some of the challenges and what would be the process that would need to go into the design before they could implement BAS? Because we have some older buildings that we're looking at doing some BAS systems, and there's some unique challenges. And I don't think everybody quite understands what else needs to be done before you can implement a BAS in an older historic building that maybe has pneumatics or has never had a BAS system. Can you talk a little bit about that?
You have to look at what's going on mechanically with everything that you have in there. Sometimes you'll have a design building where they have hot deck, cold deck. That's an older way of doing heating and cooling. So that has to be taken into account. You have to decide how you're going to control, or if that equipment needs to be removed and then you need a new air handler, or are you going to still use that? And then you have to look at the physical of it. The older buildings weren't really made for wire runs and for Ethernet connections. So that's another thing that has to be taken into account. If I have a building that was built in 1924, it's historical, can we drill holes and actually add a conduit to run the power that we need, the communications wire? Are we going to be able to do the things that we need to do to get the building automation system controllers up into place? That's all stuff that has to be looked at.
And I've actually been part of an upgrade of a building that was completely pneumatics, and then we went to digital controllers on everything. There was a study ahead of time that we were able to show cost savings, and basically for us to do all the work that was involved, it was going to be a little over $2 million, but because we were able to show the payback over a 3-year period, then it was a no-brainer because they would save more money by doing the upgrade to the digital controls, and in the long run, it would pay for itself. And you'd be surprised at how much money you can save on the utility bill just doing that.
I wanted to ask if you could each tell me one of your favorite features of BAS, but when we have these systems, there's the maintenance side of it, but also an impact on the building occupant and the cost or energy efficiency perspective. So you're welcome to jump out of your maintenance position for a moment as if you were an occupant. What an occupant would think is really cool.
I think from a tenant or building personnel perspective, honestly, I think probably one of the coolest things for them is the graphical interface. Before BAS, they had very little knowledge of what was going on in the entire building. Now they can actually click on, let's say, an air handler, and they can see everything in a graphical form that's going on within that air handler. So if there's a fan that's actually operating, then you'll see an image of a graphic spinning, animated. You'll see a cooling coil. If it's cold, if it's blue, that means it's cooling. If it's a DX, for example. So just the whole graphical interface, I think, is something that just jumps out at people right away when they look at it for the first time and they say, wow, that's my building. That's what I'm looking at. It's live data. I said, yeah. If you stop the fan, they actually see it shut off, and they can control stuff from that graphic, and they can override things if they need to. So I think that's one of the things that people really jumps out at them.
I know for me, that's what it was, because you could then see all the fun parts and pieces that go into the building automation system through the graphics. Like, you drew us a picture of how the building is functioning, which I thought was a lot of fun.
So Richard, at the same time that's a really cool feature, as these systems get more sophisticated, have they been able to maintain those interfaces in a user-friendly way? And have you found people adapting to those interfaces fairly easily?
Yeah, I think when I started doing this many years ago, the graphics looked like a kindergarten sketch, very basic. But nowadays, they're actually 3D graphics. They're much more accurate to what's actually on site. The tenants love it, usually. I haven't seen one that they don't like their no graphics. They love it. The more realistic it is, the more they seem to enjoy them.
By coming in and showing a tenant the graphics or the history, like if you took the data and trended the information off of a certain area or a workspace, and if you had a customer that was constantly complaining about the temperatures, but you could show them in black and white that temperatures have been steady throughout the past month, that we're meeting the set points, then it backs them up a little bit and say, oh, okay, well, I'm not just going to say something, because they can look back at it and show me where we have done due diligence and meeting the set points that we're supposed to give for, especially for government buildings.
Yeah, and your HVAC systems are still zoned, so Sally and Billy sitting in neighboring cubicles may still have varying temperature issues and may still complain, but the building automation system is going to tell us what the temperature is in the space, what the humidity is in the space, and then whether or not we're meeting the government recommendations or ASHRAE recommendations for what is an acceptable temperature range for an occupied location. So talk a little bit about the trends for a minute, because the trending, I think, is a vital, important part of helping the BAS technician identify if you have potential issues. So what are the trends and what does it do exactly?
Trending is pretty much data that is collected from the points on the BAS system. So for example, if you have a space temperature for a room that is critical, let's say a server room with computers, then you have the option of trending that data. So it would take raw samples, say every hour or so. You can set it up accordingly, but you can take a sample of that temperature every hour. And then if you have issues with that within that space where, for example, the tenant says that the temperature is not where it needs to be at certain times of the day, then you can look at that data throughout the whole day and see if the temperature has maintained stable or if it's actually gone up or down above the point where it needs to go. So it gives you that option to actually look at a report of data.
That's where I think that building automations becomes not just a way to change the temperature, but you're using big data to make informed decisions on how the building's operating. So where we go beyond just the ability to control, and now we can predict what's going on or identify where problems are. You can also plan. So you can schedule things on building automation too. We can implement schedules for turning on and turning off the system. So you have nighttime setbacks. And then also when the building isn't occupied, occupancy sensors can be put in. There's a lot of add-ons. What do you guys see as coming down the pipeline for future building automations? Is there anything that you're seeing that looks like the future of building automations, neat stuff that we might see in the future associated with building automations?
Going to see more AI involved with the automation systems. I know Siemens already started with start-stop time optimization in the schedule, where the schedule would actually monitor what was going on, whether it would start the building earlier or turn the building off later. But you're going to start to see more of that. I know over the last few years, you've seen more wireless BAS systems. It's not very popular now, but it's not going to be long before everybody wants to get rid of all the wires and use the Wi-Fi capability or the Bluetooth capability. So it's starting to advance more and more where the AI will take over, where the tech doesn't have to do as much, where the AI picks up the trend data like we just discussed and actually looks at it and then tells you, hey, your chillers might be failing, or it might be time to service your boilers, or these 10 VAVs are having airflow issues. It's not going to be long before that starts to become the norm.
The future, what I see is the workers, most of them have to have a security card or a fob to get through doors. We could have tracking and available processing so that the building automation will know how many people are in an area and can adjust the temperature set point accordingly, proactively, instead of waiting for the temperature to rise itself. Because each person puts out anywhere from 400 to 800 BTUs of heat energy. And if you get ahead of that so that you're not being reactive on the controls, then you're going to have a lot more comfortable setting with those people involved.
That's really taking smart buildings to a whole new level and helping to be more predictive in what we're doing. And so I think that's going to be really neat. I also like the idea of the wireless to some extent, because maybe we have sensors in a zone in multiple rooms, and it's using the sum total of that to adjust. Definitely some additional capabilities and possibilities there. Building automations is, I think, the horizon for most HVAC tech, especially if you're a commercial HVAC technician. You almost have to have building automation knowledge today, because most commercial buildings have some sort of building automation or they're leaning towards implementing it. What would you recommend for the future HVAC technician? What should they do to get ahead of this trend to make sure that they're on pace with the technology that's being implemented for their given industry?
They should come to it with an open mind. I've worked with a lot of older HVAC technicians that say hafui to the whole building automation system. They should keep an open mind and actually want to learn it, because it helps them in the long run. I know for myself, learning the other way helped me a lot to work with the HVAC technicians. And that's something that they should want to do, is work with the BAS technician to understand how the BAS is actually controlling it. Why is it taking a supply fan from, we'll say, 50% output to 100% output? What's the reasoning behind that? What's causing the chiller to start stop? What's telling it to start stop? What's the criteria for it? I think if they understand that, it makes for a better all-around HVAC technician, because now you can decide whether it's mechanical or BAS that's actually doing it. And I see that a lot when I go to different places. They'll instantly blame the building automation system for something, and it's not always the building automation system that's causing it. So for them, if they understand the relationship between the equipment and a building automation system, it would help tremendously.
You guys all came up into building automations through a lot of hands-on experience, but what certifications did you have to get in order to do some of that back-end programming?
Depending on which company that you work for or with, they have their own set of training and maybe even some proprietary stuff that you had to learn. I know Siemens, we had to learn proprietary programming. So you learn from that. And then dealing with the state of Florida, Siemens didn't win every contract for every building. So there was Johnson Controls. There were a bunch of the other mainstream controls that were controlling other buildings around. So I had to learn how to take the basic concepts and then adapt them to the different formats and the different user interfaces for the different controls to be able to maneuver through that system. Back to a little bit about the question before, the facilities guys, if they can understand that the building automation can actually make their life easier. So instead of having one guy walk around the building and look at the chillers and write down all of the information that the chillers have at a certain time of the day, you can automate those reports so that at the same time every day, you would get all of the information that you would normally have to go down and look at the chiller to write down, but it'll all be automated. So it saves time, it saves effort, and makes that technician then more productive for the building itself.
Tony, do you find that to be a generational thing, or the ones who do adopt it and realize the advantages, do you associate that more with a person or a generation?
Well, it used to be it was hard to teach an old dog new tricks, but I've also come across somebody that was 80 years old and they knew more about the new electronic side of building automation than I did at that point. So it just depends on the person and the individual. A lot of times we resist change. A lot of people don't get past the growing pains and see what potential is there. Like, hey, not only can I go check out an air handler, but I know this automation system and I know that automation system, and I can automate this and make things easier. And then for one example, their building was strictly nothing but telephone servers. If the main power was lost and the generator came up, the generator was sized maybe 10 years ago, and it was for a certain amount of usage. But since then, they've made plenty of upgrades and brought in more equipment. So we had to turn around then and make a load shedding program that would allow the system to come up and not spike up the voltage and the amperage that would cause that generator then to lock out, and they would be completely without power. There's a lot of things like that where I don't necessarily consider it generational. I just consider it informative. Like if that person is willing to see all the benefits that building automation can provide and look at it with this is a tool type mentality instead of this is something else I have to learn, then it's going to be more beneficial for them and the facility manager in the long run.
We've talked about preparations for people within the field, how you guys got where you are, and quite a wide variety of pathways as you guys demonstrate even just among yourselves. So for somebody who might be interested, hey, I think that building automation system sounds like something I would be interested in. Even though there's lots of ways to get there, is there a type of pathway or training that you might recommend for somebody just beginning to explore career options?
I think having a good understanding of technology in itself, computers, that would definitely help. I know that helped me a lot. Also, taking maybe an HVAC course so you understand the equipment. I know here locally in Virginia, the community college here actually offers an HVAC certificate. And I think it's about 2 years. It's an actual associate's degree. But part of that program is the theory of building automation, just understanding the concept of what the building automation system does. So I would definitely look into classes like that. There is also online, there's a ton of free stuff that you can read and just constantly look at online. I believe ASHRAE does just basic theories on HVAC and then some of the building automation as well. So I would definitely look into that.
Yeah, I agree. I think electronics is a major player. You need to know what relays are. If a relay went bad, be able to identify that, diagnose that. You also need a little bit of programming knowledge, a little bit of deductive reasoning and logic flow analysis. Basically, all this deals with computers and computer programming. So if you can understand that the computer is stupid and it's only going to do what you tell it to do or what somebody that programs it tells it to do, then that will be both beneficial in debugging the programming and also adding on to it and improving the programming over time.
You guys are doing a lot of stuff overseas now, too. Are you seeing any difference between the US systems and the systems that are overseas? Are other countries adopting or ahead of us? Are the systems different, or is it largely the same technology?
It's a little bit different when you're inside the U.S. Embassy because it's built to our specs. It's usually built for our comfort pretty much. So stuff like that stays the same. I know that when I do go into other buildings overseas, I will take a look around just because I'm a nerd like that, looking at BAS systems, and I'll try and figure out what they're doing. But the thing I do see is when I do talk to the local staff is their concept of what should happen versus ours. That's where I see the difference. So if you got a chill water valve that's supposed to open up, they might think it should open up earlier, whereas I say wait till this point, and then we can creep the valve open. So that's where I see the difference. I just know that the thought process between me and the other technicians is a little bit different on how they view things.
You've both had experience at Siemens, and sometimes you may be limited by, okay, this building is Johnson Controls. It sounds like there's a lot of information specific to a particular manufacturer. I understand that there are some types of controllers that are meant to be, I don't know if you'd say more universal, that you can use to control different types of systems. I believe Tritium Niagara. Could you speak a little to that universality, and moving forward, will there be less limitations as far as what products or manufacturers?
That's really dictated by the customer. I know over the last 6 to 10 years, what I've seen is that a lot of customers don't want to be binded to one company. They want to have the ability to cost willing that they could go to Johnson Controls if they find that it's cheaper, or they can go to Schneider. So you're going to see the communication protocol for building automation open up a lot more now. I know that they've tried it with BACnet and LawnWorks. I think you're going to see a lot more systems with Tritium just because it's open. It doesn't bind the customer to exactly one system. You can take that Tritium system and then integrate it into another system and pull points in. We were just discussing that earlier today, sticking an actual Jace somewhere and pulling points in so that the customer doesn't necessarily have to get rid of the old controllers. I think you're going to see more of that over the next 5 to 10 years. Major companies will still sell their stuff, but it's going to be more open for them just to get in and be in building.
Absolutely. And I agree with that 100%. And then the open platform also allowing the legacy devices that are already there. Let's say you want to be able to talk to that and still be able to upgrade to new devices in new areas, or if you're doing a remodeling or an effort to revitalize that building, then it allows you the option of keeping the communications with the old stuff and then getting the new stuff in and being able to talk to everything and integrating it all into one central point, whether it's a server or a workstation, that will then allow the facilities people to better manage what they have and to use it for troubleshooting purposes, or just to sit there and say, I can tell you exactly what we have at the building moving forward. Like this air handler is over 20 years old, so it's past its life expectancy. So we're going to need to upgrade this air handler very soon. And while we're upgrading the air handler, we need to upgrade the automation of that air handler. And when we do that, we need something that's going to actually be available on the open platform instead of being locked in to an older version of controls and not allowing that ability to basically build on what's there.
One other thing that is obviously on everybody's mind over the last year are issues related to COVID. I don't know if you could speak briefly to any additional challenges that you have faced the last year due to COVID and how you may have overcome them and what had to change in the way you do things?
As a recent example, we've had an area where the government entity says we need to have more outside air coming in and we need to change our filters and we need UV lights to disinfect the air coming through the system. Well, all that's possible, but we were able to save a building thousands and thousands of dollars just based on the fact that we could take the automation and basically send it to a night setback. And then at night, you're flushing that building with new, fresh air. So you have that exchange of the air that's been inside the building recirculating to a bunch of fresh air coming in. And there's CO2 sensors or other gas sensors that show the parts per million. You could actually get black and white what you're doing at night and how well it's working to exchange that air so that new fresh air is going to be more healthy for the occupants that are involved.
I've seen it. I know at the last trip, that's what the technician did there. They just pretty much automated it so that at night it would give them all fresh air. And then he switched it to a little bit during the day as well, where he would flush the building at least once or twice a day.
So that saved us from actually changing the filters to a higher filter. So let me back up for a second. Filters are rated, but their rating also changes the amount of airflow that go across the filter. So by getting a better filter, you're actually decreasing the amount of airflow that's going through that system. So if you can purge the air out at night and get new fresh air in the morning and then be able to adjust the outside air damper to allow more fresh air in during the day if you need to, then you're not only saving money by not having to buy newer filters that are more restrictive, but you're saving the wear and tear on that air handler as well because it's not having to work as hard. Less flow means more work on the air handler. If you can do it without changing the filters, which would reduce the airflow, and you're able to keep that fresh air coming in, and again, show it in black and white that the parts per million, whether it's CO2 or other gases, you can show in black and white that you're making those changes and it's affecting the air quality of that building.
So in effect, you have been able to get approval for those changes because you're able to demonstrate that the ultimate goal is achieved, and that is only possible by being able to have that amount of data and to back it up.
Exactly.
We see declining workforce, more difficult to find people to fill those positions. Sometimes trades or people think, oh, I'm not very technically inclined. I'm probably not suitable for a field related to HVAC. But from what you are telling me, BAS could be a field that even if you're not the person who's actually going to repair a piece of equipment, that there's quite a wide variety of skills that could allow somebody to enter this workforce and be effective.
Absolutely. I've been in the industry over 20 years, and I have 0 college degrees to my name. All of my stuff has been through training, through hands-on experience, and listening and learning from people that are way smarter than I am. You don't necessarily have to be the expert, but if you get in and start understanding things and learn, and then can take that and use it to think about how things can be better, then that forward thinking is what a lot of people are looking for. It includes them in the process, and they can feel productive that they've made a difference in that industry or that company or that building.
I know for myself, I got thrown to the wolves right away. So after my little 2 weeks, first 2 weeks in the office, I thought everything was great. I read my little books, and then they sent me out with my mentor. Literally, I had a laptop, and my mentor told me to plug into the controller, and I had no clue what was going on, and he would not explain anything. So I had to learn. I started listening to the techs that were around who had been doing it for a while, and they would give you things to look for that would help you in troubleshooting. I think for myself, I'm just a naturally inquisitive person and want to fix stuff. And I think very logically a lot of the time. So it helps a lot. I know here locally, I have friends that still work for Siemens, and they're no longer out in the field. They're programmers for Siemens. They actually set the programs and the graphics, and they actually send it out with the technicians. And then when the technicians have issues, they can support them because they understand what's going on. And they understand the building automation system, so they can help them. So it's not necessarily just hands-on. There's a lot of stuff that you can help with and be very productive.
Sounds good. Well, we really appreciate your guys' time today. It's been amazing. I think we have an amazing group of staff at IEI who are at the forefront of building automations and definitely building a pathway for government, commercial buildings to really embrace building automation upgrades and changes. And I look forward to the future and implementing more AI and helping with more predictive maintenance. So that way we're running buildings even smarter than we do today.
Thank you so much for joining us today and appreciate your conversation. And I'm sure a lot of people appreciate understanding how you got where you are and be inspired by that and hopefully motivated to possibly have a career in building automation.
Thank you for joining us on Level Up Stronger. For references to resources mentioned in this episode and to receive updates on future podcasts, check us out on social media or at levelupstronger.com. And remember, each time we take risk, educate ourselves, and apply what we've learned to our lives, we level up stronger. Each time we level up stronger, we have the opportunity to reach back and contribute to someone else's success too.